So what do we know about parabolas? At the moment, we know that the most simple kind of parabola is y equals x squared. That's like the parent one. But a parabola can get this complicated, right? Ax squared plus bx plus c. And we also had some other forms. Remember, this is the standard form. There was also x minus p times x minus q. What was that form called? That was called intercept form. And there was one more. The last one is ax minus h all squared plus k. And remember, that one is vertex form. Okay, so remember the x-intercepts here are p0 and q0. And here the vertex is hk, right? And the a represents whether or not it opens up or opens down. If it opens up, then a is positive. If it opens down, then a is negative. Concave up and concave down. Today, however, we're going to look at a new way to describe the equation of a parabola. And it's like this. If I look at, say, y equals x squared, right? I can actually write this another way like this. X squared equals y, and it kind of comes from here. The correct way to do it is this. X squared equals 4 times p times y. So what the heck is the p? Well, looking at this one here, if I'm going to write this in this form, x squared equals 4 times something times y. What's the p in this case? P in this case would be 1/4. Okay, so this stuff here is going to be the same. What's the p value? P is called the focal length. Now, what's focal length? Well, to define focal length, I have to tell you something called the focus. What's the focus? This is the focus here. At some point here, focus. And the focus is, have you ever seen the inside of like a flashlight where the bulb is? It's kind of like this 3D parabola shape. It's exactly what it is actually. It's called a paraboloid. And you can imagine that the focus is the light bulb. And when light comes out, it will bounce off the parabola and go vertically or like straight up. Same over here. Bounce, and it'll go that way. Bounce, it'll go that way. Bounce, it'll go that way. My diagram's not very good, but these lines here are all parallel. Okay, so this parabola shape, 3D, it actually, if it was a mirror, it would actually shoot light straight out in that shape right there. This shape is also used in satellite dishes. So when, in other words, information like radio waves are coming this way, they bounce off the satellite and they go into the focus. So satellite dishes are also this shape. So it's kind of used in science a lot. So the focus is that point where we have that effect happening. Okay. So what is P again? Back to P. P is this distance. All right. P is that distance. Okay. Down here, this is still the vertex H. Okay, that is still the vertex. That's not going to come up today though at all, but this distance here, okay, that is P. And we get another line, so this comes to the new definition of a parabola. So I've got a focus and I've got another line here. This line here is called the directrix. So you've got vertex in the middle, focus, P units up, directrix, P units down. So directrix is a line, be careful. So in this case, it's a horizontal line. The equation will be y equals something. And the focus will be hk moved up 2 units. So in this case here, it would be like h and k moved up p units is going to be k plus p. All right, it's not really a formula though, but when you see an example, you'll see what I'm talking about. And what is the directrix? Well, another definition of the parabola is it's a point which moves so that it traces out a path such that the distance to the focus and the perpendicular distance to the directrix is always the same. All right, so the parabola will be traced out by this point. And as it moves, it's got to stay the same distance away from the focus and the same perpendicular distance away from the directrix. And if you just keep moving this point under those conditions, it will trace out a parabola. So that is another way to define a parabola.